Hello guys, welcome to my channel. Today we are going to solve the Leetcode problem, merge two binary trees. The question is that given two binary trees, and imagine that when you put one of them to cover the other, the some nodes of the two trees are overlapped while the others are not. So you need to merge them into a binary tree. The merge rule is that if two nodes overlap, then sum node values up. So you have to sum the values as a new value of the merge node. Otherwise, the not null node will be used as a new node of the tree. So basically, what it means is that we are given two binary trees, and we have to merge these two binary trees, and the merging values, the values that are the nodes that are overlapping, we have to add those sum of the add those values of the nodes. So like if we take the root values, 1 plus 2 is equals to 3, the sum will be 3. And similarly we go to the child values also, 3 plus 1, the same type of, we are overlapping it. So 3 plus 1 equals to 4, and 2 plus 3 5. Similarly, now the case is this case, otherwise the not null node will be used as the new node. So the thing is that the 5 is not here, this is not present here, so we are just going to take the 5. So it's like we are adding 5 plus 0 is kind of like that. So it will be like that, and there's 4, there's no value for that, and 4, it will be 4 only, and after that 7, it will be 7 only. So this is the this is basically the question. And the merging process must start from the root nodes of both trees. So it should start from here. Okay, no problem. Now the algorithm we are going to use here, you can see in the right hand side, we are going to use breadth first search, level of the traversal. If you don't know that, I think you can search. I'll post a video maybe about that. I'll explain, so no problem. We are going to use a queue, that is, it has FIFO, first in first out capability. So what we are going to do is first add two nodes, the root nodes. Okay, first root nodes, we're going to add it into a queue. Okay, say this is a queue, the highlighted portion, and we are going to do is pop the elements. That is, it will consist of two elements, because two trees are there. We are going to traverse it consecutively, so like two binary trees together we are going to traverse it. So t1 t2, we have popped the two elements, and after that we are going to add those values and put it into t1 actually, and put it into t1. Oh, sorry, t1 equals to. So we are going to add these two values inside, t dot. Well, it's kind of like that. Okay. So we are going to do is modify the t1 and return it, right? And after that, after adding this, we are going to add in a queue again the right and left, of the popped elements. The elements which we popped, right? We have to check the other child values also. So we are going to queue, add it in the queue again, the right and the left node. Okay. So after that, we are going to continue it until queue is empty, and after that we are going to return t1. Okay. And the time complexity will be on, and the space complexity will be on, because we are storing in a queue and we have to traverse all the elements. Okay, let's code it up. So first we are going to check if both are null. If both are null, we are going to return the null value, right? So if t is equals to null and t2 is equals to null, we are going to return t1. You can return anyone. Okay, if t1 is equals to null and t2 is not equals to null, if that's the case, we are going to return which is not null, that is t2, because we need to add it, right? So 0 plus something like that. So because the t1 is null, so it will overlap, right? 5 in this case, so it will overlap, right? So yeah, so returning t2, and if t 1 is equals sorry is not equals to null, and t2 is equals to null, then we are going to return the value which is not null, that is t1. Right. After that, we are going to do this one, add initialize a queue. So queue of type tree node, queue equals to new linked list. Okay, and we are going to add this one, add the root values first. Q dot add t1 and q dot add t2. Okay, now we are going to traverse it while q is not empty, right? Because not queue is not empty. While queue is not empty means it will traverse until the queue is empty. In this case, what we're going to do is pop the elements, right? Pop the two elements. In this case, so tree node a equals to q dot poll, because in q it actually poll. Okay, and tree node b is equals to q dot poll. Okay, and we are going to add this thing. It can be written exactly, but let's say a dot val is equals to, or we can just give it like this, a dot val is equals to a dot val plus b dot val. So it's modifying the values, right? And after that, we are going to actually this portion, add right and left, right? So we are going to check this if anything is null, right? If a dot left is not equals to null and b dot left is not equals to null, then we're going to add q dot add a dot left and q dot add b dot left. Right. If a dot right, we are going to check the right child. If a dot right is not equals to null and b dot right is not equals to null, then we are going to add q dot add right, which is the right, sorry, a dot right, and q dot add b dot right. Okay, now one case is that if a is null. Okay, so next case is that if a dot left is null, if it's null, what we are going to do, and of course b dot left is not equals to null. Okay, not equals to null, we are going to do is a equal a dot left. We are just assigning the value of b to a, so a dot left is equals to b dot left. Simple. Now here we also have to check the b child, right? So we're going to do is q dot add b dot left, but one more thing we need, right? So what we are going to do is q dot add new tree node 0. Okay, same thing for the right. We're just gonna copy paste this, copy and paste, so it will be for the right, which is the same thing for the right one, right, and here also right. Okay, now the opposite case, if a is not null. Okay, if a is not null and b is null, we don't have to do anything because we are only going to return the first. A is representing t1 here because first in first out, right? So this is the first element. So yeah, so we don't need to check for if a dot left or right is not equals to null and b dot left is equals to null. So we can just return t1 here because t1 will be modified. think I think this is clear. So right, after checking all this, it will just modify the t1 because a is representing t1 here, first in first out, right? First in is t1. Yeah, so we return t1 and after that we can just check it. Yes, so let's submit this. Right, that's it. Thank you for watching.